Topic 1. Main type of methodologies in the assessment of desirability and economic and environmental social aspects of constructing a highway proposal. Topic 1. Economic appraisal. Economic appraisal techniques can be used to justify a scheme in absolute terms, in which case the decision is made on the basis of whenever the project is economically efficient or not. A negative net present value or a benefit cost ratio less than unity would indicate an inefficient scheme where society would end up worse off with a scheme than without it. The economic benefits occurring to the beneficiary of the highway would be exceeded by economic costs incurred by those losing out as a result of its construction. Cost-benefit analysis. This method usually adopted for the economic evaluation of highway schemes. Term cost-benefit analysis utilizes the net present value technique where the costs and benefits of the scheme are discounted over time so that they represent present-day values. Using this method, any appraisal having a positive net value is economically sustainable in the absolute terms. Identification of the main project option. This is a fundamental step in CBA process or cost-benefit analysis process where the decision makers compile a list of relevant feasible options that they wish to be assessed. It is usually to include a do-nothing option within the analysis in order to gauge those evaluated against the baseline scenario where no work is carried out. The dominium option offers a more realistic course of the action, where no new highway is constructed, but a set of traffic management improvements are made to existing route in order to improve the overall traffic performance. Identification of all relevant costs and benefits. The application of cost-benefit for project assessment in the highway area is made from complicated by the wide array of benefits associated with a given road initiated. Some easier to translate into monetary values than others. The primary grouping that contains this type of economic gain is termed users' benefits. The benefits of this type accrue to those who will actively use the proposed installation. This grouping includes reduction in vehicle operating cost, saving in time, reduction in frequency of accidents, economic life, residual value, and discount rate. A highway project is often complex and long-term, with the costs and benefits associated with it occurring over a long time frame, which we term the life of project. Parameter dealt with the earlier chapters, it sets a limit on the period over the costs and benefits are estimated, as all must occur within the time slot, be it in 25 to 35, even in 30 to 50 years or more. It is related in principle to expected lifetime of the project under analysis. Use of economic indicators to assess basic economic viability. Once the two parameters of project life and discount rate are set into place, this allows all costs and benefits to be directly compared at the same point in time. The decision maker must now choose the actual mechanism for comparing and analyzing the costs and benefits in order to arrive at the final answer for the net benefit of each of the project option under consideration. Any of the three techniques listed earlier in this chapter can be used for this purpose. First is the NPV or net present value, IRR or internal rate of return, or B or C or benefit cost ratio. Advantage and disadvantage of cost benefit analysis. The advantages: the use of the common unit measurement money, facilities, comparison between alternative highway proposal, and hence aids the decision-making process. Given that the focus of the method is on benefits and costs of the highway question to the community as a whole, it offers a broader perspective than the narrow financial investment appraisal concentrating only on the benefits of the project developers, be the government or a group investors funding toll scheme. While the disadvantages, the primary basis of constructing a highway project can be societal or environmental rather than economic one. If the decision is based solely on economic factors, however, incorrect decisions may result from confusion of the originally primary purpose of a proposed project with a secondary consequence simply because the less important secondary consequences are measurable in money terms. Payback analysis is extremely simple procedure that is particularly useful in evaluating proposals just as privately funded highway projects where tolls will be imposed on users on the facility in order to cover construction costs. The method delivers an estimate of the length of time taken of the project to recoup its construction costs.
Environmental appraisal of highway schemes. The cost-benefit framework for a highway project is only concerned in transport, efficiency, and safety, and not in the effects to environment. Environmental evaluation requires an alternative analytical structure. That structure is termed environmental impact assessment, which is developed within the last 30 years. Data's minimum information that must be contained within the environmental impact statement include a physical description of the project, a description of measures envisaged to reduce the significant adverse environmental effects of the project, the data required to identify and assess the main effects on the environmental of the projects in questions. And sa 12 environmental impacts forming the assessment framework are: number 1 is air quality, number 2 ay cultural heritage, construction disturbance, ecology or nature conservation, landscape effects, land use, traffic noise and vibration, pedestrian, cyclist and community effects, vehicle travelers, water quality and drainage, geology and soil, fallacies and plants. Tabular presentation of data kung saan nakasama is yung the main impact sa proposed highway scheme. At the early stages of the highway planning process, the environmental impact table format can be used to consider the alternative route corridors, and ang design manual for roads and bridges, ina-advise na ang EIT o yung environmental impact table be constructed for all relevant appraisal groups.
Topic 2. Basic elements of highway traffic analysis.
I am going to discuss the speed flow and density upstream of highway. The three microscopic measures of the state of a given traffic stream are flow or flow rate, speed, and density. Flow or flow rate is the number of vehicles passing a point or some designated roadway in a given time or period. Makukuha natin yon sa pamagitan ng formula na Q is equal to N over T, wherein yung N is yung number ng vehicles sa isang lugar or sa isang lane, and then T represent the given time period. Speed is the distance traveled by a vehicle during a unit of time or vehicle's rate of motion. Density is the number of vehicles occupying a unit length of roadway at an instant in a time. Formula niya is density is equal to the flow rate over the average travel time for unit distance. At ngayon naman ay i-discuss ko ang relationship between speed density, flow density, and speed flow. The relationship between the speed and density is when the density reaches its maximum level, the speed will become zero. The most simple assumption is that this variation of speed when density is linear. Corresponding to the zero density, vehicles will be flowing with their desired speeds or free flow speed. When the density is jam density, the speed of the vehicles becomes zero. It is also possible to have non-linear relationship. Para makuha ang speed density relationship, ang equation ay speed is equal to the free speed minus the free speed over jam density multiplied by the density. Dito naman sa flow density relationship, kapag zero ang density, zero din yung flow kasi syempre kapag walang density, ibig sabihin walang vehicle. Ikalawa is when the number of vehicles gradually increases, the density as well as flow increases. Habang dumarami ang sasakyan, tumataas din yung density at pati na rin yung flow. Sa pagdami ng mga vehicles ay dumarating sa punto na kung saan yung mga vehicles na yun hindi na makagalaw. And it refers as the jam density or maximum density. By substituting the speed density equation to the flow rate equation, we can get the flow is equal to free speed multiplied by the density minus free speed over density jam times the square root of density. Speed flow relation makikita natin na kapag mababa ang flow rate, ay magkakaroon ng tsansa na makapag-travel ang isang sasakyan into a maximum possible speed. At kapag naman nasa maximum flow, yung speed ay between 0 or free flow. To find the relation between speed and flow, kailangan lang nating i-substitute ang density formula sa equation 1 and then makukuha na natin yung flow is equal to jump density multiplied by the speed minus jump density over free speed times the squared of speed.
The level of service approach. It is a qualitative measure describing operational condition within a traffic stream. The operating condition is graded from best to worst, designated by alphabet A to F. Level of service is used to analyze highways by categorizing traffic flow and assigning quality levels of traffic flow and assigning quality levels of traffic based on performance measure like speed, density, delay, and etc. Some definition. In order to determine a road's level of service, a comprehension of the relationship between hourly volume, peak-up factor, and service flow is vital. Hourly volume of B is the highest hourly volume within a 24 hours period. For peak-up factor is the ratio of the hourly volume to the peak 15 minutes flow enlarged to an hourly value. Service flow is the peak 15 minutes flow enlarged to an hourly value. Maximum service flow rates for multi-lane highways. The highway capacity manual generates maximum flow values obtainable on a multi-lane highway given a certain speed limit and prevailing level of service. Given the extent of ideal condition, the maximum service flow can be defined as C sub j times parenthesis volume to capacity ratio times n, where C sub g is the capacity of a standard highway lane for a given design speed j, and n is the number of lanes in each direction. So this is the values of C sub j for the different design speeds. For the maximum service flow rates for two-lane highways, the capacity of these highways is expressed as two directional value rather than the one directional value used in the previous section for multi-lane highways. Under ideal condition, the capacity of a two-lane highway is set at 2,800 passenger cars unit per hour. If one adjusts his value by a ratio of flow to capacity consistent with the desired level of service, the following formula for service flow is obtained, kung saan ito ay service flow divided by 2,800 times parenthesis B over C sub I. So, ito yung ideal condition. If ideal condition obtained, the service flow is obtained using the ratio of flow to capacity associated with the required level of service. Sizing a road using the highway capacity manual approach. When sizing a new road, a desired level of service is chosen by the designer. This value is then used in conjunction with the design traffic volume in order to select an appropriate cross-section for the highway. And in order to derive this value for a highway, the annual average daily traffic for the highway is multiplied by a term called the K factor, such that design volume equals K sub I times AADT, where the value of K sub I corresponds to the 80th highest annual hourly volume. Estimation of annual average daily traffic. Selection of the appropriate layout for a rural road requires that the high and low forecast for the opening year is estimated. This is undertaken using the factors supplied in this table that are used in conjunction with present-day AADT figures to produce future flows. These are matched with the appropriate annual average daily traffic range in table 2 in order to choose the right carriageway type.